Well, good morning, everyone. Good afternoon, wherever you may be. My name is Michael Wrightson. I am the general manager here at Neverfail. Welcome to the global presentation that we have today. This telecast is kind of special to me because I'd like to talk about disaster recovery. And if you've ever read my blogs, it really has it really is designed to educate people about how to build disaster recovery plans. But in this telecast, we're going to talk a little bit about how we can take a disaster recovery plan and elevate it to business continuance. So what is business continuance? So business continuance is really about protecting the most critical applications that really power your business. In fact, these are the applications that if they're not available to your end users, you're basically out of business. So these could be revenue-driven applications. These could be anything that has to do with sustaining life, maybe even certain types of infrastructure applications. These are all technologies that hold up the business and keep the business moving. And so what we're going to do is we're going to talk a little bit about business continuance today and how Continuity Engine and Neverfail as a whole can help you to elevate your disaster recovery plans from a disaster recovery type of strategy to business continuance. In fact, we call this the organizational guide that can help you to be successful in this area. So with that in mind, what we're going to do is we'll talk a little bit about our agenda for this morning and for this day. We're going to talk a little bit about what causes downtime first, and then we'll get into disaster recovery planning. What are the different components of a disaster recovery that you need to really focus in on? Some people think that a disaster recovery plan is just essentially just buying a set of tools that they can use to recover IT systems. But it's much, much bigger than that. And we'll talk a little bit about the different aspects of a business continuity plan. We'll also talk a little bit about what the difference is between business continuity and disaster recovery. They are completely different, although they are similar in nature, but we'll talk a little bit about the differences. And then we're going to talk a little bit about how you do business continuity planning. And then we'll have a very special guest, Mike Baker. Mike Baker is with Stanchion Payment Solutions, and he'll be joining us to talk about his experience using Continuity Engine for what's going to be very surprising of how critical the application that he supports is. And then what we'll do is we'll talk about how Continuity Engine can actually help you to achieve business continuance. So with that in mind, let's get started. So when we've, throughout the history from, day immemorial, if you will, we've always tried to figure out what are the causes of downtime and what, especially in the new, the information age and IT, we see that there are a lot of different things that can cause downtime. And so, back in the 80s and 90s, we really focused in on data corruption and natural disasters. Those were basically what we focused in on, maybe some hardware outages, but that was really the focal point of most disaster recovery plans. And then as we got into the 2000s, we started to realize that there was gaps in what could be protected for the current types of technologies that were available. So, usually it was a data protection technology along with some type of clustering, but there were still gaps in how you could protect the application, and more importantly, how fast you can get the very mission critical application back. So the idea of the focus on applications and networking really became the focal point, certainly from the time of virtualization around 2000, 2002, somewhere in there, up until, really the last few years. And so with that in mind, we have a lot of, applications, thousands, tens of thousands of applications that run on different types of physical and virtual hardware systems, and they need to be monitored in order for us to be able to provide the level of protection that is required. But in the last few years, we've really started to see that there's been a focus on another two areas where we see a lot of activity, and that is in the area of human errors, where people just do pilot error stuff, and systems are either taken offline or they're crashed or whatever, or rendered useless, or the infamous malware or ransomware plague that we have on us right now. So all of these are really different types of causes of outages that we are seeing today. We don't see as much hardware failure anymore because the hardware is really, really good. But what we do see is a lot of application problems and things like networking related issues, and of course, ransomware. So it takes a really good disaster recovery plan to be able to accommodate all of these different risk areas, if you will, when it comes to BCDR. Now, when you look at the different costs of an incident, there are many different statistics that are out there. But really, when you look at what happens during a major outage, the small business is really suffers the most for these things. In fact, 90% of small organizations fail if they don't reopen within the first 5 days after an outage. Now, is that even possible in some types of disasters like a major earthquake, or a massive flood, or a hurricane? In these types of areas of the world where these things can happen, and in some areas of the world, both of them can happen at the same time. So you're talking about the Pacific Rim, and even in the Caribbean in the United States, these things could happen almost simultaneously. So if you don't have a good disaster recovery plan, when you get hit with these types of disasters, 90% will not even be able to reopen their doors because they just are not ready for this. 20% of organizations without tested business continuity plans are likely to survive that. So out of 100%, 80% of these businesses would probably not, they would not survive it. Only 20% that have business continuity plans will. So it's really important that you plan these things out and you go through all the different scenarios that are likely to happen. The average cost of a disaster is somewhere around 100 to 300,000. I guess it's up to debate whether those numbers are exactly accurate or not, because that is a big wide gap. But the key thing to take away from these types of incidents is that when they do happen, they usually are extremely costly, right? And the average time for an organization to have to absorb this type of incident and be able to come back from a major disaster is about 200 minutes. So think about an organization that has a revenue-driven application, which we will actually talk about a little later on in the presentation. What 200 minutes means to a revenue-driven application. And give you an example, we had a not-for-profit in Washington, D.C. area about 10 years ago when I first started at Neverfail. They had an application that was externally facing, and since they were an NGO, they got a lot of their revenue from donations. And actually it was about $70,000 a day. They had their entire operation on a single server, and it was externally facing, and it went down. They lost the storage. Storage just died on them. And it took them almost a week to get back into business. So with that in mind, they obviously contacted us, and we were able to build redundancy for them so that an application-aware failover, so that this would not happen again, but the damage was already done. They had lost a couple $100,000 in donations during that 1 week. So it was a very costly type of error. So this is really the downtime. The cost of downtime can be very large in an organization. And so it's important that we have a disaster recovery plan. So why do we need to have a disaster recovery plan? Well, there is actually 4 reasons why we need to do these. The first is to minimize disruption for day-to-day operations. I think that is pretty much a no-brainer, right? That's what we're designing for. And so with minimizing the impact to the day-to-day operations of a business, we have to figure out what it is that could be interrupted. And sometimes that takes a little bit of thought on the part of not only the IT team, but the greater business. And I'll give you an example. After Hurricane Sandy hit the Northeast, about a decade ago, I actually lived in the New York, New Jersey area. So I saw the veracity of this type of hurricane when it came. And it was very unusual that we would have a strong storm like that come into that area. But it did. And one of our customers, which became a customer after this is done, they had applications that they thought were protected. They focused in on the core IT systems, but what they didn't realize is the rest of the business had critical applications that were department level and they weren't protected. And so when their data center went underwater because of the water surge in the southern part of New York, Manhattan, they were going back to backups. They were literally going back to backups for mission critical applications, which cost them a lot. So the idea here is that you need to plan for these types of disruptions. And even through, with day-to-day operations, you could even have things like bad disk, you could have networking problems, these types of things, and even human errors. These types of things have to be planned for. And you want to reduce the financial impact of these types of disasters. So when you think about the financial impact of this, what are we talking about? Well, we're talking about, having to buy new equipment, new networking might have to go in, telecom services have to be restored. You may even have to have office space just to house your employees. All of these things have to go into this. So this is part of the financial impact. But what about things that you don't really think about, like the legal impacts of a disaster and being able to get access to resources on the fly? So I remember one time there was a disaster, massive flooding event. And the big thing that happened was they had the money to be able to restore or to buy all brand new equipment. The problem was the equipment wasn't ready because everybody was asking for the same equipment. So it took them weeks and weeks to be able to actually buy the equipment that they needed. So there was a major financial impact to this because they couldn't get access to those resources. And then there is you need to really kind of think about the alternatives of, how to, if things go south on you, how do you really get your operations back into production, and if the plan goes south? So you almost need a plan for the plan, right? So and you need to do this in advance of downtime, right? So it's not like you want to wait until the disaster happens. You want to be able to have plan B, if you will, if certain types of things are not there. So it's one thing to have a great plan, and maybe you even did some level of testing, but then, disasters don't always go right? They're not predictable. That's the whole purpose of them, right? And so you may have to alter the plan a little bit in order for you to get to where you need to be. And so that needs to be taken into consideration. So at the end of the day, you want to provide smooth and rapid restoration of business services. And so this is where technology comes in. So being able to use the right technology along with your plan to restore business services becomes critical, right? So you don't want to use a hammer to kill an ant, right? So there are different types of technologies that are used for different types of applications. The way we deal with this is through what we call application tiering. So you take your applications, you decide how long you can live without it. You put it into a tier, which is usually 1 to 5 or 0 to 4, right? Each one of those tiers will have a different type of hammer, if you will, or a different type of product that you can use to protect those applications. So you don't want to use something that can recover in 30 to 90 seconds for something that you don't need for several days. So there's some planning that goes into this, and that provides you with that smooth and rapid restoration of business services. So how do you prepare for a disaster recovery plan? So there are 7 areas in which you can use your, during your planning to provide the right level of, or the basic data, if you will, to be able to provide the disaster recovery plan and prepare for that. So the first thing, as I mentioned, is you got to tier your applications. So understanding your RPOs and, and RTOs is essential to making this work. So you have to kind of look at, document first all of your applications, make sure that you understand what those applications are and what, more importantly, what the value to the business is. Can you live without them for several days, or do they need to be back immediately? Are they applications for business continuance? Then you need to determine the technologies that will fit into those tiers, right? Those SLAs, if you will. So as I mentioned, you can certainly use backup for certain types of applications, but maybe not for the most critical applications. You don't want to restore a mission critical application from backup. So these are the types of things that you need to match your technology with your SLA. Then what we found is you need to understand interdependencies of applications. This is an area in which a lot of people fail. So when you look at different types of applications, there might be other systems that it's drawing data from or receiving data from, right? And if you don't understand what those interdependencies are, then when you build your disaster recovery plan, you could actually be missing systems that you thought were valueless, or maybe they didn't have, they had a higher, a higher RPO and RTO, but were actually critical to another system that was actually down. So understanding these dependencies is critical and is a part of your disaster recovery planning. Then you need to just determine the criticality of these non-IT managed systems. So if there are departmental systems that need to be, that need to be looked at and brought into your disaster recovery plan, you need to see how critical they are, and then add those to your tiers, if you will, your tiers of applications and your RTOs and RPO defined for those applications. Then you need to determine the times in which you need to test, right? So testing is everything. When I talk to my customers and they talk about building, disaster recovery centers, I said, what's your test plan? And they're like, well, we're just going to test it every now and then. I said, no, what is your test plan? That's not a plan. That's basically saying, okay, we're just going to test every now and then, make sure it works. So you need to have a, definite number of times a year that you want to plan your testing, and you should be preparing for those events, so that you can make sure that all of those mission critical applications, the ones at least for business continuance, I call those either the tier 1 or tier 2 applications, right? They can be brought back instantly to protect the core of the business. And then you need to analyze the cost of implementing this versus using other types of platforms like, cloud services or whatever. So a lot of organizations have to think about, are we going to do this on-prem in our own cloud in a different data center in a different area? Or are they just going to buy services from somebody else, right? They're going to have their own cloud, cloud service from Amazon or Google or Azure. But those decisions have to be made. And then finally, is, we don't always think about security framework around around business continuity, but the really, NIST and ISO outline business continuity planning, if you will, business continuity requirements for cybersecurity frameworks. So these are things that you could take into consideration as building your disaster recovery plan, because NIST and ISO really provide a comprehensive approach to security, and you can't have security without business continuity. Okay, so now let's talk a little bit about the differences. So we talked about, we use these terms business continuity and disaster recovery, but they're not really the same, right? They are similar in nature. One is really focused on being proactive. It is focusing on keeping the business operational during the disaster. But during a disaster, you are in reactive mode, right? So there's a planning piece of this that's more proactive. So you understand what you need to do. But then there's a reactive piece of this that says, okay, well, we're up to our waist now. How do we get out of the quicksand, right? So this is the disaster recovery, focusing on restoring data access in IT systems after a disaster actually happens. A business continuity plan also focuses in on business operational survival, right? So the effectiveness of that business continuity plan can limit the operational downtime. But when you're looking at it from a disaster perspective, a disaster recovery, though, it really focuses on IT systems. So the business continuity plan is much more about the business itself, but disaster recovery is really focusing in on IT systems. And so the business continuity plan is really about, it's all inclusive, right? It is about the restoration of mission critical systems running across all aspects of the business to provide near zero downtime and provide you with the ability to tier off and have different plans for different types of applications. But the disaster recovery plan is really a subset of that, right? So it's kind of linked together. They're part of the same document, but it is really a subset. So it's really designed for safeguarding a company against all contingencies, right? So, it is designed for restoring those critical systems. All right, so then, when you look at the business continuity planning as a whole, right, there's three aspects of this that you really need to take into consideration. First is what we call high availability. So what is that? Well, it is the ability for you to ensure that if something happens within the application hardware or, within the application itself, the server itself, that you can ensure that it can be restored very, very quickly. So these failures might be, in business processes and physical facilities, or even in IT hardware or even software. But high availability ensures that when something goes down, it can be restored very, very quickly locally. And then there is what we call continuous operations. So the second piece of your business continuity planning is to protect the ability to keep things running during a disruption, as well as during planned outages, as like such as scheduled backups, or even disaster recovery tests, right, and planned maintenance. So this is kind of a little bit different angle of the business continuity planning, in the fact that you're still in normal operations, but you got to, if you're going to do any of these ancillary type of tasks, such as, a disaster recovery test, you don't want to impact the production environment while you're doing this. So this is very, very important for you to plan for these things, and to be able to and to have those built into your disaster recovery plan and business continuity plan. And then finally, as we talked about before, disaster recovery is about recovering your operations in a different site in case something destroys your production data center. And so this is really designed for the recovery of the business itself when it's been otherwise rendered inoperative. And so all of these really are the three key aspects of your disaster recovery planning. So when you go into this process as a team, as part of your organization, you can plan for these. In fact, if you are a reseller, or maybe you're a systems integrator, these are things that you can use to, and there's a lot of documents out there that are free on the internet. You can use these to kind of pull a disaster recovery plan together for your customers and be able to guide them through the process of developing this. So there's a lot of things that are resources are available to help you to do these things. So essential elements of the business continuity plan, there are actually 6 essential items that you need to consider. We've mentioned a lot of these already, but now let's talk a little bit about this on a higher level, right? So if I'm a planner, if I'm going to start building business continuity plan, there are 6 areas in which I'm just going to focus in on, and then you can start breaking those out into subcategories, right? So identifying critical functions. So that's the first thing that you want to look at is what happens if the organization's broken, right? What are the critical functions of this business that I need to restore very, very quickly? And then you have to do a risk assessment. So if these certain systems are down, what is the risk to the business? That allows you to prioritize and even provide that tiered approach, if you will, or an SLA, because you know that certain types of applications represent a bigger risk to the business. And then you got to do what we call a business impact analysis. So this is a special type of, and there's a lot of documents that are out there on the internet. You can actually download free templates for business impact analysis, but it predicts the cost of downtime and looks at how users can gather information to develop different types of strategies for building your business continuity plan. So this is I think actually is the start of your business continuity plan, is by starting with that business impact analysis. Having a communication plan is also essential. So, by default, when you have a disaster, it's a chaotic type of situation. So when you have a good communications plans with, the employees and shareholders, users, customers, even your supply chain, it's going to be critical to get your business back up and operational. So IT is only one of the things that you need to do, but even within the IT organization, you got to be able to communicate with your team. And what happens if there's a disaster and people are spread all over the place and they can't get to the office? How are you going to group the IT team together? And how are you going to execute that business continuity plan? So communications is very, very critical to make sure that this happens. And then you have to have a test plan. Test, test, test. So I always tell people to test. So if you think this is a good plan, and even if you've done weeks and weeks of planning, you think it's good, you're going to find problems with it, right? So the only way to flush out all of the problems is to be able to test it on a normal basis. And then, one thing that people don't really understand is the business changes over time, right? So that's why it's a continual process. You test, 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 right? And, we came across a customer that had that problem, right? They tested, once a year, and they thought they had a great process, but, every time they tested once a year, they found that there was some type of thing that they've overlooked, right? Which is a good thing, but because they didn't test, right? They only did it once a year. If there was a disaster, it probably would have been of a significant impact to them because they weren't really prepared, right? They always found these holes. There was applications maybe that they thought were mission critical that were decommissioned. Or maybe there was equipment that was older that didn't, if they have to do a DR to it, they may not be able to get the old equipment that is designed for that application. So there's a lot of different things that they could have ran into during this test that they need to flush out. And the way you do that is you do it often and a lot, right? So I have one customer that does it every 3 weeks. Now that's kind of extreme, honestly, but I really applaud their attention to this, right? They really take business continuity seriously. And so they literally do their DR tests, they actively move all of their IT systems to different data centers and just run for 3 weeks off of those data centers every periodically, and they go between 2 or 3 data centers. So this is really a good way of ensuring that your business is protected. And then finally is continuous IT operations. So organizations should have the ability to switch seamlessly to another instance of the same app or data. And so that takes planning, right? If you're going to do the seamless transition, you got to be able to understand what it's going to take to flip those applications and make sure that they have the data that they need to operate. And more importantly, you need the tools to be able to do that. I mean, it's extremely difficult to do that stuff manually. So you got to have intelligent tools to be able to help you to do these things. So the idea here, guys, is be able to plan your disaster recoveries and be able to look at the systems that are mission critical to your business to be able to ensure that they are doing what they need to. So at this point, I'm going to open this up to an interview with a guy who I really admire a lot, Michael Baker, who is the development manager over at Stanchion Payment Solutions. And he's been doing development work to help to, automate payment systems for banks. So you think about how mission critical that is, right? If you can't pay or process credit card transactions, what does that mean for a bank, right? Well, Michael is the guy who engineers these types of applications and requires, of course, for the banks, they need to have disaster recovery. So, Michael, welcome to our program. How are you?
Yeah, I'm good. Thanks, Michael. Thanks for having me. How are you doing?
I'm doing well. So, it's been, we've known each other for a while. We've been doing business, and, Stanchion is, not only a partner of ours, but you're actually one of our heavy users of the technology also. So,
right.
So what is it that, that Stanchion does?
All right. So Stanchion is a systems integrator providing services primarily to customers in the payments processing environment, as you mentioned. Our customer base includes large financial institutions, merchant retailers, and processors globally. And really, we're talking about anyone who's processing card-based payments or any form of digital payments nowadays. Our services include providing, end-to-end project delivery for these customers. So we will go along and analyze business requirements. We'll help them with the solution design, build custom software, implement the solution, and then ultimately help them take that software and that solution through go live and post go live support for the customer. A significant portion of the work that we complete is based on a product suite by a company called ACI Worldwide, and the product suite is named the Postillion product suite. And it's the core financial processing switch and ancillary products that provide switching services for these banks and retailers. Stanchion's got a strong global presence, so we've got offices in all the major territories that one would expect. And additionally, we've developed our own payments integration platform that's named Verto. And really what it is it's a framework that enables us to rapidly integrate particularly more modern web-centric technology interfaces such as REST endpoints into the traditional payment rails that one is aware of, such as the ISO 8583 message-based payment rails that the legacy banks and retailers typically use. Additionally, we have a managed service component of our business where, because these payment systems are so important and particularly complex, we provide that functionality to our customers to help them, share our expertise and help them run and operate their switch in their environment.
Yeah, so I guess you would say Postillion is a mission critical application, right?
Yeah, absolutely. I mean, the short answer is a resounding yes. To give that some more color, I guess I'll just elaborate what the Postillion application does. So it's a monolithic architecture authored in Java, and it runs on top of a Microsoft SQL Server stack. So that's the environment it's typically deployed into. The core function, as I mentioned earlier, is primarily to route these financial transactions. And like I mentioned, it's typically card-based, but it's other forms of digital payment as well. There's obviously a strong emphasis on transaction integrity. So, we can't have data loss in this environment. Things need to be strongly consistent, when processing these transactions. So at a minimum, we provide this application suite provides this switching functionality. There are ancillary products. So there's a authorization platform named Postcard, which provides authorization services. So that in that case, a bank, for example, wouldn't necessarily have a host system that they make use of, but they would all be using Postillion to do the authorization of a transaction. Some retailers will make use of that product as well for the purposes of doing stand-in. So should for some reason their acquiring bank have an outage, the retailer can make risk calls and authorize those transactions locally. So in terms of, I guess to clarify whether it's mission critical or not, a good way would be to say, well, what would the impact be if there was an outage? In the case of a financial institution such as a bank, what we're really talking about is all the acquisition channels and issuing channels. So essentially what we're saying is one could imagine all ATMs that the bank drives would be impacted. They would all be down. No one would be able to transact at those ATMs, both the bank's card holders as well as other banks' card holders that might make use of that ATM. Additionally, there would be no opportunity for a bank's card holder to transact at another bank's ATM and have their transaction authorized. And any of those card holders wouldn't be able to transact at a retailer unless that retailer was providing some sort of services, standard functionality, because the bank was down. So it's without a doubt a mission critical system. It is the core of the card-based processing system within a bank or a retailer.
It's funny too, because I've heard different statistics here in the United States that people have 2 credit cards, usually, and I do. I actually have 3, yeah. But usually what happens is if you swipe your credit card and it doesn't go through for some reason, that's probably because maybe the back end system didn't work properly. So what's going to happen next? You're going to take out your second credit card from another bank and you're going to swipe. So it really is a revenue thing, right? It's for
absolutely,
banks. Absolutely. Yeah. So although you had the choice of different types of continuity solutions available to you, what drew you and Stanchion to Neverfail?
So I mean, like you mentioned, there are existing solutions. There's a fundamental difference between Neverfail's approach and the predominant existing solution that exists. That being that the alternative makes use of concurrent processing nodes. So in other words, you deploy a secondary active server that's actively processing transactions. With doing that, you have a significant increase in complexity in that one has to synchronize that application state between the 2 nodes. And you have all the typical problems one would expect with concurrent processing. That's further exacerbated by the fact that the nature of the business is that it needs to be strongly consistent. And the read-write profile of the application is fairly balanced. So there's quite a lot of writing of data, and there's also quite a lot of reading data. So with the other solution that's available, you're doing that synchronization and all of the smarts to try and ensure consistency exists at the application layer. Now that's quite different from the Neverfail approach, and that's really what I guess drew us to Neverfail. With Neverfail, the synchronization at the OS just made so much sense to us, because what we're really doing is we're saying, let our application focus on being good at what it does, which is processing these payments. And we'll let the Neverfail take care of the responsibility of making sure that data is synchronized and available at the secondary partner. Additionally, with Neverfail's decision to make use of this clone-based architecture with, active server and a warm passive server that we can rapidly switch over to, that was a clutch decision. It it further decreases the complexity in that deployed solution. So we only need to worry about maintaining and operating really one server. Our worldview hasn't expanded to include 2 concurrent models. Now we've really got the same sort of deployment topography, so to speak, as we had before, but we have the ability of having this high availability tech built in now. And I think the last important point, and you just touched on it, in your previous slides, is that having a DR site is one thing. Having a plan to shift over to that DR site is another thing. And then actually having exercised it and tested and knowing that it's going to, meet those requirements when the pressure's on and your system is out is a completely different ballgame. And that's what we've often seen with customers that do have, just for example, passive DR sites. At that point, there's a mad scramble to try and get the data to the DR site. How much data am I losing? How long is it going to take me to bring it up? When we bring it up, we find that we can't connect to nodes because IP addresses and things are wrong, etc. So having the automated approach within Neverfail, where we can script these operations and rapidly do that switch over, is just such a win. So with Neverfail, we're really getting a like for like in terms of availability. We're getting a fraction of the time to roll these solutions out to customers. Like I mentioned earlier, with the whole synchronization being at the OS layer, what it really means for us is we can roll out a very consistent, high availability solution to our customers who differ in terms of their complexity. And that solution remains, consistent across these customers, which means we can provide a good service to them. And I think the big one is that we're not increasing the target environment complexity once the solution is deployed and is now in place. And that's significant.
Very good. And so what is your experience working with the Neverfail support and PS teams? I mean, this is a very complex technology that you're working with. So, what has been your experience working with our teams?
Yeah. So, we've had the luxury, obviously, of working with the Neverfail team through, all aspects of project delivery. So we engage with Neverfail when we're in the pre-sale cycle for a customer, and we obviously continue to engage with Neverfail through implementation and go live. And it's just been a truly wonderful experience. We've received fantastic support from the Neverfail team. And, one really gets the impression that the team is proud of their product and stands behind it. And it reflects in the quality of service we're getting. I guess the other thing I would want to say is that, when you're buying a product, you're buying a whole bunch more than just the ones and zeros in a compiled binary. You're getting into partnership with the person providing that product. And, I couldn't think of a better partner to choose than Neverfail for our high availability.
Well, that's great, Mike. I really appreciate your time joining the broadcast today. It's really a testimony of, what the true capabilities of this technology are and why, not only our resellers, but also our integration partners and even, our customers, why they choose this type of technology to deploy into their environments. So thank you so much for your time today. I really appreciate it.
Yeah, my pleasure. Thanks.
Okay, so let me just go back to our presentation here. So now let's talk a little bit about Continuity Engine, and we'll kind of a little bit elaborate on Michael's comments here, and we'll talk a little bit about what makes this a special technology, right? So, interestingly enough, our technology is designed for the most critical applications. So, when you're looking at things like data protection technologies, these really protect the zeros and ones. And some of the data protection technologies do have replication in them. They do have some basic failover capabilities, which is really more reactionary, right? So if something happens, usually people are down, they call the help desk. There's some triage work that has to happen with, once the tickets are open with the infrastructure teams. And you know how it is. There's an anatomy of an outage, right? There's the understanding what the problem is. And then, there's a whole set of different types of tasks that goes through before you even get to the process of restoring data. So although data protection technologies and basic failover are okay, right? And they are designed for certain types of applications that require, don't require, seconds to minutes recovery time. There is a place for those, but you got to understand that it's going to take time to restore those systems, even with products like a Veeam backup and replication, or maybe a Zerto that does have that instant recovery capabilities. There's no intelligence on the front end that says something has happened and we need to react to this. So the idea of both basic failover and data protection and even clustering technologies really have to be augmented with a continuous availability solution. That's where Continuity Engine comes in. So in this next slide, we're going to talk a little bit about the process for recovery. So remember, one of our biggest differentiators is that we have technology that can actually see things that are happening inside the application server. So things like human errors and application services, and then when they're down and the performance of the application, maybe it's not performing the way we expect it to, or its accessibility. Even things like within the operating system, whether there's core services that keep the operating system healthy or it's performing badly, networking, and hardware failures, all of these things come together with Continuity Engine, and we provide an intelligence layer that can detect all of these things, and it monitors for it 24/7, 7 days a week, right? It's never off. And so this is where for mission critical applications that can't afford to go through that triage type of anatomy process, anatomy of the outage, you don't want to wait for them to kind of figure it out, right? That's what the intelligence is for. And so what Continuity Engine does is first is to enable your applications to be able to recover within seconds to minutes. We basically create a clone copy of the original server, and they're firewalled from each other. So only Continuity Engine traffic goes over this. And so as we have, the only way to truly ensure that the application will be available within a very short period of time is to give the users back what they lost, the original server, right? So we clone a copy of the original server, we firewall it, and then we run real-time replication to keep the data sets for those applications running continuously. So we're talking about recovery point objectives of milliseconds, maybe a couple of seconds, where recovery time objectives are measured in 30 to 90 seconds, which is amazing. Then what we do is, with real-time replication is great. It keeps your loss of data down to a bare minimum, but it also can become a bit of a nuisance, if you will, if you have things like ransomware or massive corruptions of data. So that's where our data rollback augments our real-time replication. So if there is some type of massive corruption from server one primary, maybe it's ransomware, or maybe you had massive disk corruption or whatever that just killed databases, you can still fail over to the isolated server one secondary, and it has a snapshot copy periodically of the data where you can roll back to those and restore the data. So now you don't have to worry about massive corruptions of data and getting your application that's revenue driven back up and operational, such as the Postillion application. You just basically roll back a little bit to just before maybe that ransomware attack happened or whatever, and you can just fail over and you're back in business. So, this is an amazing technology that really gives you the full complement of the things that you need to do to protect those applications. Now, with continuous monitoring on top of this, this now really gives the intelligence that we're talking about, right? So it looks at the performance of the application, the accessibility, the services, responsiveness, the operating system itself, networking around it, and it's implemented through threshold rule sets. So now it's basically different rules that are looking at different aspects of the operating system and the application and the server itself, the hardware, and it can correlate these different events happening. And then for some reason you lose a service, right? Continuity engine can literally detect this over the channel. Server one secondary can see that server one primary is offline and promote itself to active status. That is that is why this technology is so unique, is that we can detect those things that other technologies, the basic failovers, the data protection technologies, replication technologies, and even just backup and restoration just cannot see. It fills those gaps of the different events that could potentially take down mission critical applications. And so we do this with zero distance limitations. Every node can be managed, flexible deployment options. It's really designed just to keep people working. Okay, so there are different types of use cases for this. I'm just going to kind of go through this real quick. We can always have a deep dive discussion, but just keep in mind that the high availability, which we talked about earlier in our presentation, is the primary use case. With the ApplicationAware Failover that has all of those different types of monitoring rules, if you will, that is really monitoring. The secondary and the primary monitor each other for those different failure events and can fail over automatically. And it's done on the same local segment, which is good. It's kind of in the same data center. And so full automatic ApplicationAware Failover, no waiting for the IT teams to respond to this. It just, the intelligence layer shortcuts the entire anatomy of the outage, right? It just gets you right to the restoration process. And then there's what we call effortless disaster recovery. And disaster recovery is essentially the clone copy in a different data center, different network segment, if you will. And we optimize the bandwidth going between the primary and the secondary server, since it's going over a wide area network connection. And then if something happens, you can push a button and restore the server literally within 30 to 90 seconds. Now, can you actually have automatic failover between data centers? Yeah, you can. It is possible to do that with Continuity Engine. But DR, typically customers want to have control over that process, just because. And so that is the default configuration, but it can be automatic if you need to. And then finally is what we call tertiary. And tertiary is kind of the best of both worlds. So you have a 3-node configuration that gives you both that intelligent high availability locally, and then also disaster recovery, which is that 3rd node. So you can have really covers you across all major threats, fills in all the gaps that we just talked about, and gives you absolute protection when it comes to major types of outages, right? So think about, emergency management systems, or building environmental systems, or, medical systems, people, heart monitors, things like this. You want to make sure that you have absolute recoverability. And so a tertiary deployment provides you with that level of flexibility. So just before we finish up here, I wanted to kind of extend another testimonial. This is an interview that we did with Christopher Lasky at Marsh Wortham, maybe about 3 years ago. But because of the way, what the disaster that he faced, which was a hurricane in 2017 in the Houston area, I thought it would be a great way to kind of finish this presentation. And so with that in mind, I'm going to tell you his experience.
Now, realizing that it's one thing to hear this from Neverfail as the vendor, but another to hear it from an actual peer, I would also like to introduce Christopher Lasky from Wortham to talk a little bit about his experience in this arena, assuming that we've got the audio all connected up. So Christopher, are you there? Are you online?
Yeah, I'm here.
Great. Well, thank you for joining us. Appreciate it. If you would please talk a little bit to the group here about kind of your experience as it pertains to kind of this anatomy of an outage or disaster recovery and some of the things that you've done to help your business mitigate.
Yeah, sure. To give everyone a little bit better understanding, we've been using the Neverfail products for several years. I've been at Marsh Wortham almost 10 years now, and when I was brought on board, we were using it then. It's been probably, I would say, some of the best performing software that we have here in terms of its reliability, ease of use. You know, starting out, I was briefed by a senior employee here who was more familiar with the application. And, you know, over the course of 10 years, I've become more familiar with it. And now I'm the basically lead in charge of the software. And of course, Marsh Wortham, we're in the Houston office, so we're in the Gulf Coast region. You know, the biggest impact that we've seen is probably what everybody's expecting, which is Hurricane Harvey absolutely destroying some of our offices. You know, we got two of our bottom floors got filled full of water. All the electrical was gone. It took almost a full year for our building to be repaired. You know, having the flexibility to, you know, on demand switch our applications seamlessly to our secondary site is absolutely critical. It saved us, I mean, you know, hundreds of man hours. I was actually out of the country at the time, and this is the second time I've been out of the country during a horrible disaster. And I, of course, dreading this hurricane coming and knowing what it would do to our business, you know, really was the difference between life or death. It would have been very difficult overseas to connect in and start trying to initiate some kind of long recovery process, but Neverfail, it was seamless, a few clicks of a button. And, you know, we initiated our switchover even before the hurricane had made landfall in Houston, knowing the impact that would occur. So yeah, it's been, like I said, some of the most easiest and definitely some of the best time consuming software that I've used here. We use it for all of our Exchange servers, our large document management system for the entire firm, which is about 14 terabytes of data for not just Houston, but we have offices in every city in Texas, Austin, San Antonio, Fort Worth, Dallas, and they all deposit documents in the same centralized file repository, which we keep synchronized to a secondary server in case we have any issues, which we have in the past. And then we use it for a few critical SQL servers as well. So a lot of applications that are deemed mission critical, cannot go down whatsoever, are all protected by the Neverfail solution. So it has just been something that I can't say enough good things about it, because it has saved me personally a tremendous amount of time and work making sure that our applications are protected. And, you know, I've lived in Houston my whole life, and I've been through 2, 3-ish large storms already. And so I can't imagine anyone who lives in an area that gets hit with these things every, 5 or 10 years wouldn't want something to keep it protected, just because of the nature of hurricanes and what it can do to your business. That's been my personal experience with the software over the last couple of years.
So Christopher, if I heard you correctly, you have so much confidence in Neverfail that you don't mind leaving the country when disasters are coming, because you know you can press a button, right? Maybe just go hang out at the time.
I wouldn't tell my boss that. But
appreciate your time, and I'm sure that folks on this line, it was very helpful as well. So appreciate it.
Okay, so a little bit of a humor there, but what's nice about this, guys, is that this is a real testimony from real people using Continuity Engine, and so it's this is what we designed it for, right? We designed it to restore business services, or even proactively move your business to a different place and be able to do it effortlessly. And so that is really the benefits, one of the benefits of Continuity Engine. So when you look at the intelligent high availability, it's really designed to identify and proactively react to these types of failures. It gives you a 100% hands-off approach. Pretty much in a local HA, it's fully automated. In Chris's case, he was away, and he was able to just push a button and move his operations just ahead of the storm. So it was, the automation, the orchestration process is really second to none. being able to manage in certain parts of the world bandwidth, and it's some bandwidth is costly, some of it is maybe not as reliable as it could be. That's also a major benefit of this, right? Being able to reduce the amount of replication traffic. It's a very powerful but elegant type of solution that provides for business continuance. And that is really the point of this entire presentation. And it's not overly engineered. It's very simplistic. It does one thing and one thing well. It fails over Windows servers. We're in version 9 of this technology. That tells you exactly how good this is. If we've only got to version 9 after 20 years in the business, that's really testifies to the maturity of the product. And so you can use this in different types of networking configurations and different, physical and virtual hardware. The orchestration process, as I mentioned, is flawless between even locally and between, different data centers. When the actual process is triggered, even locally, based on rules, it only takes about 30 to 90 seconds to bring your systems back online. If you're at DR, and even if you're half a planet away, it's still 30 to 90 seconds, which is amazing. And the key takeaway from this is that for a disaster recovery type of scenario, the same process you use to bring it over is the same process you use to bring it all back. It is absolutely amazing. And, that is really the trick. A lot of technology gets you over to a DR site, right? Whether, depending on the complexity and, different, the reliability of it, right? But even if that's the case, we'll just say everything fails you over quickly. The getting it back to production has always been the challenge for a lot of technologies, and we make it effortless with Continuity Engine. So before we let everybody go and enjoy their day today, some people are in the morning, some people are in the evening, and we really thank you for joining us today. If you would like to do a deep dive of Continuity Engine, you can go to neverfail.com/webinar/engine-demo. That's neverfail.com/webinar/engine-demo. Register for a demo, and we will give you a Continuity Engine dark mode t-shirt if you register for a demo. So we really look forward to you. If you have come to us through a partner today and joined us, then just obviously reach out to your partner, and they can actually schedule those demonstrations, and we will give you a t-shirt. The other thing that you may want to take a look at is my blog. If you haven't been acquainted with it, it is a great source of information and my personal view of the business continuity industry as a whole. The continuityguy.org is the place in which I really kind of provide this level of content, right? It's a great blog. And it, I do, articles periodically every couple months or something. I'll put out a new article. But there's a lot of great content out there, and we hope you enjoy it. thecontinuityguy.org. And it's also available on Facebook too. If you do the Continuity Guy and do a search for that, you'll see it pop up. And also on Twitter, the handle is continuity_guy on Twitter. And that brings us to the end of our presentation today. And if we have some questions that we can answer, we can kind of open it up for questions right now. Okay, so the first one, it says, a limitation AI is the management of false positive. How does your solutions cope with that? All right, that's actually a very good question. We use threshold rule sets, right? So essentially, we keep retesting to see if certain things happen. And then if certain things do continuously happen, we have the ability to take multiple different types of actions, right? So we can start with, say, sending you an alert, right? That says, okay, we see this. Then we retest maybe a couple minutes later if we need to. And we can say, okay, maybe we'll try restarting an application, the application service or the entire stack. We'll see, and then it continues to monitor to see if there's an issue. And then if there is a, continuation of this, as we've tried to resolve this, maybe the third time, the third recovery action can be, fail over to another copy. So we have different types of things that we can detect anomalies. Some things can be corrected and through these recovery actions, these up to 3 of them that we can take. But there are other things, such as like what happens if if the channel fails for some reason, or maybe the wide area network goes down. Those things could also be tested for, and we can actually put what we call failover avoidance rules in place for split brain and things like that. So, we can detect whether it's just a networking problem or that's causing the channel to go down, or we actually have a real event where the servers are offline, right? So it's a very mature technology. We have a lot of rules built into this, and it continues to get better. So as we see that there are new things that we need to test for, we continue to add it to the software, because really at the end of the day, that's what we're about, is ensuring that the intelligence is there to be able to detect these things. So that's a very good question. Okay, well, that concludes our broadcast for today. Thank you for joining us today on behalf of our entire team, and thank you, Michael Baker, for joining us today. Really appreciate your efforts here. And on behalf of the entire team here at Neverfail, thank you and have a good day.